Hello students, in this video we'll see an example of how to solve a constant coefficient ODE with repeated complex roots. Let's consider the ODE, the sixth derivative of y, plus 9, the fourth derivative of y, plus 24, the second derivative of y, plus 16, y equals 0. So this is the sixth order constant coefficient, ODE. So we can write this with our differential operator notation as d to the sixth plus 9d to the fourth plus 24d squared plus 16 applied to y is equal to 0. And to simplify this problem a little bit, we notice that every power of d is a power of 2, is a multiple of 2. So I can let script d be equal to d squared. And then this will tell us that our operator is script d cubed plus 9 script d squared plus 24 script d plus 16 applied to y is equal to 0. And now we can use the rational root theorem to determine the possible rational roots of this. So we have that the possible rational roots are going to be plus or minus 1, plus or minus 2, and then the factors of 16 are 4, 8, and 16, so plus or minus 4, plus or minus 8, and plus or minus 16. Furthermore, I know since there's only positive expressions over here, I can only look at the negative roots. So let's test negative 1 first and see what happens. If we test negative 1, we'll have a 1, a 9, a 24, and a 16. Bring the 1 down, negative 1. I'll have an 8 over here. Negative 1 times 8 is negative 8. 24 minus 8 is 16. And negative 1 and 16 is negative 16. And so we get a 0. And so this is a root. And so our factorization becomes fancy d cubed plus 9 fancy d squared plus 24 fancy d plus 16 is equal to fancy d plus 1 and then fancy d and then squared plus 8 fancy d plus 16. And this is a perfect square, so this will be fancy d plus 1. And then fancy d plus, if I put a 4 squared, I will have the factorization since this is a perfect square. Now we replace fancy d with d squared, so this really is, our problem is really d squared plus 1, and then d squared plus 4, quantity squared, applied to y equals 0. The d squared plus 1 term is going to give us plus or minus I, so I will have y equals c1 sine x plus c2 cosine x from this term over here. And then I will have sine of 2x and cosine of 2x, so c3 sine of 2x plus c4 cosine of 2x. And since it's repeated, we'll have these times x as well. So c5x sine 2x plus c6x cosine 2x. The repeated root always generates a factor of x when I have it to the second power. If it was to the third power, I'd have x squared terms as well. Thank you very much.